In this video, we are going to talk about some other trigonometric ratios. So let's talk about some other trigonometric, Trigonometric, trigonometric ratios. So what I'm going to do, I'm going to pick up where I left yesterday. So the very first thing what I'm going to do, I'm going to draw a small triangle over here, which is a right triangle. So let's pretend this is my right triangle A, B, C with right angle at C. And we all know that side opposite to A is small a, opposite to B is small b, and opposite to C is small c. If I consider my angle A as my reference angle, REFERENCE reference angle, if A is my reference angle, then side opposite to C, vertex C will be hypotenuse, TENUSE, hypotenuse, and since A is my reference angle, then the name of the side opposite to reference angle is opposite, so A will be my opposite, and name of the side next to reference angle is B, and the name of that side would be adjacent. ADJACENT, adjacent. So what I'm going to do, I'm going to write it over here. So the first thing we will write, what is my hypotenuse? HYPOTENUSE, hypotenuse, which is, I'm going to use capital H for hypotenuse, and hypotenuse, as you can see, is C. My opposite is OPPOSIT, opposite. I'm going to use O for opposite, and my opposite, as you can see, is A. And the last thing that I have is adjacent, and I'm going to take adjacent as A, and as you can see, capital A is my what? B, because adjacent is small b. So what we did in last video, we figured out what is my sine of A, and if you remember, sine A is opposite over hypotenuse, and you can see my opposite is A over hypotenuse, which is H, and that is equal to C. So my sine is opposite over hypotenuse, which is A over C. Let's talk about cosine. Cosine A was adjacent. I'm using A for adjacent. Adjacent over hypotenuse. And just to remind you, adjacent, I'm using adjacent as A, opposite as O, and hypotenuse as H. So my adjacent A is B, so I'm writing small b, over my hypotenuse H is C, so I'm writing small c. And the last thing that I had was tangent A, and tangent was opposite over adjacent. So opposite O is A, so I'm going to write a small a, over adjacent, capital A is B, small b. So I have my sine as opposite over hypotenuse, which is A over C. Cosine is adjacent over hypotenuse, which is B over C. And my tangent is opposite over adjacent, which is A over B. Now, the next trigonometric ratio that we have, they are reciprocal of these trigonometric ratios. So the first trigonometric ratio that we are going to talk about is reciprocal of sine, and we call it cosecant A. And since cosecant is reciprocal of sine, So we need to find the reciprocal of the whole thing. So reciprocal of sine would be cosecant, and as you can see my sine is opposite over hypotenuse, so my cosecant will be hypotenuse over opposite. And my hypotenuse is C, so I will write C over, my opposite is A, so C over A. Opposite of cosine is secant, so I will write SEC of A. And since secant is reciprocal of cosine, so I'm going to write the reciprocal of cosine, which is adjacent over hypotenuse, will be hypotenuse, I'm using H for hypotenuse, over adjacent. So my hypotenuse is, as you can see, C, that is C over, my adjacent is B, so C over B. Now let's talk about the reciprocal of tangent, and the reciprocal of tangent is cotangent, so I write COT, and some people write it cotangent altogether, but I'm writing only like COT, cotangent of A, and cotangent is reciprocal of tangent, so I'm going to flip it. So instead of writing opposite over adjacent, I'm writing adjacent over opposite. And my adjacent is B, so I will write B over, my opposite is A, so I will write B over A. So as you can see, the reciprocal of sine is cosecant. So if I know sine, I can find cosecant, and if I know cosecant, I can find sine. In the same way, reciprocal of cosine is secant. So if I know one, I can find the other one. In the same way, reciprocal of tangent is cotangent. So let's write another relationship over here. So the relationship that we are going to write here is basically from this relationship. So just to remind you, cosecant is C over A, but sine is A over C. So as you can see, they are reciprocal of each other. In the same way, secant and cosine, and tangent and cotangent. So the next relationship that we can write is sine of A is 1 over cosecant of A, because one is reciprocal of the other one. And in the same way, we can write that also implies that cosecant is equal to 1 over sine. Now let's take these two relationships, cosine and secant. So cosine is 1 over secant. So my secant will be, of A will be 1 over cosine. And my last one is tangent. So tangent is 1 over cotangent. And if I want to write in terms of tangent, so I can write cotangent is equal to 1 over tangent A. So as you can see, if I know sine, cosine and tangent, I can easily find cosecant, secant and cotangent, and vice versa. So now you can see we have 6 trigonometric ratios: sine, cosine, tangent, cosecant, secant and cotangent. And this is how we can define all the trigonometric ratios.